this, and we'll talk a little bit about the non-right triangle stuff towards the end here. But the last little bit that we worked through, a week from yesterday, actually. A week from yesterday, so next Thursday, we're actually going to do a little, I don't want to call it an experiment, but it's a little lab, if you will. And I'll send out emails, and I'll make notes, and we'll remind you guys every Tuesday, we'll remind you on Wednesday and all that. Next Thursday, we're going to meet downstairs in the auditorium for class. Do you guys know Mr. Severino? Yeah. May or may not have known him from, he's an instructional coach. He taught, he's one of the teachers here in the high school forever. He and I went to college together in Northern, and we had taken a whole bunch of the same, you're all in the same classes and all that. We were all in the same classes, and some of the things that you have to do is you get your teaching degree, you develop lessons, you develop activities, you do all this kind of fun stuff. And one of the activities we developed was this thing for what's called angle of elevation, angle of depression. And what we're going to do is we're going to use what's called a clinometer. A clinometer, you guys all know what a protractor is, right? Yep. Okay. So basically what's going to happen is we're going to take a protractor, it looks like this, I believe. That's not actually badly drawn for myself. Well, remember, this is where all the little markings are. Okay. So what happens is, what we'll do is, like in the middle here, there's a little dot space. What we do is we take a string. And on the edge at the bottom of the string, we put a little paper clip. That little paper clip basically accounts for a weight. So weight, it keeps the weight of the string down, so the string always is vertical to the ground. And what we do is we take this clinometer piece here, actually, so if I can do this real quick. What we're going to do is this. We're going to take the clinometer and we will rotate it, and then the string stays vertical to the ground. Okay? And this tells us angles of what we're looking at. And we can measure distances. Have you guys ever seen, I'm sure all of you guys have seen construction people out on the side of the street, down the streets, they've got the sight, and there's a guy down the road holding the thing, they're shooting a laser beam at it. What they're doing is measuring distances. They're using a high-tech version of the clinometer. Any of you guys ever use a golf rangefinder or a rangefinder if you were hunting or anything like that, where you're looking at distances? It's basically the same idea. Where they're measuring distances using, and all it is, it's using trigonometry to do it. This is just a rudimentary, but a very, very, I don't want to say rude, but a crude way of doing it. It's just a very basic way. And it works out really well. So Seb and I came up with this little lab thing probably 15 years ago when we were in class together. And we've been using it at the high school ever since. So every year we do the same thing, and it works out really well. You guys have a little bit of fun with it. It's just something different to do. It's actually hands-on math experiment, if you will. So that'll come in next week. But before we get to that, we have to talk about what exactly are and how angles of elevation and depression work. So let's define it. Angle of elevation. I can spell this. Now, angle of elevations. There's only one elevation. And depression. This is actually pretty simple. You guys ever heard of the term called line of sight? What is it, Jim? No, just heard it. Oh, everybody know what it means? What are you doing? Exactly. Everybody hear me all right? It's perfect. Line of sight is what you're looking at straight ahead. So if you're standing here, let's see if I can draw my silhouette. Yeah, see, it's me standing here. Little spiky hair. See this baby shade of hair. All right. So line of sight. You have such the look of what the hell was he doing? It was just perfect. Just the way the smirk on your face, I can just see it going through your head, going. Anyway, line of sight. Just like Christian said, line of sight is when you're looking horizontal. Your line of sight is always parallel to the ground. You okay with that? So what happens is we talk about what's called an angle of elevation versus an angle of depression. Angle of elevation is line of sight looking up. All right, line of sight looking up. So if I'm standing here, move this out of the way real quick, and up on a light pole, there's a light pole up there, and there's a bird. We'll say it's a blue jay.
Like a mushroom.
Squint, it looks just like a bird. See? Thank you. All right. So I can say that. Hello. Oh, thanks. I didn't get you anything though.
It's okay.
All right. Cool. So. Angle of elevation is this idea of what's called line of sight looking up to an object.
But is he actually looking up or you just see him?
The line of sight from here looking up, so I don't move my head, I just look up. All right, so that's line of sight up, is angle of elevation. So if I knew that I was standing, I don't know, 30 feet from that pole, and I knew that for some miraculous idea that I knew that the telephone pole or the bird happened to be, I don't know, 25 feet up in the air. What information would I have to figure out to figure out the angle of elevation? What's now careful there. It's like a triangle, you're right. Think about this real quick. And this, I went with the, normally how I start things really easy, and then I get the hard one. Start with the more difficult right off the bat. Do we know what this distance is? We know the whole thing's 25. What am I missing? All right, first of all, not drawing a scale. What am I missing? Okay. Do I need the hypotenuse for this problem? No. I need to figure out this part here, don't I? What would this part be represented by? Think about the diagram. What is it? That's all before my eyesight is. See where I'm going with that? How high up are my eyes going down? See where I'm going with that now? Yeah. So we'll say that's 6 feet. I'm 6'3", so we'll say it's about 6 feet. Okay. So if this is 6 feet, again, not drum scale. How much is this? The rest. How much is the rest? Yes. 19. Good. So if this is 19, and just like you said earlier, this is circle my theta. That's my opposite. This is my, what's my trig function? Tangent, very good. So from there I would use tangent. Tangent of theta is 19 over 30. How do I find theta?
Oh, wait, I want to do it.
Inverse, very good. So you would inverse it. Press some buttons, what do you get?
0.0.
Did you forget inverse?
Oh my. 32.35.
32.35, okay. Does that make more sense? All right. Again, what we're doing here is we're using basically a picture as opposed to a triangle to draw something. Okay. We're going to interpret. What's that? Sometimes there's pictures given to you, sometimes there aren't. Yes, ma'am.
Thank you.
They're always fighting.
I know, right?
And she took my somebody and she put in my bag. Why you thought she had no clue that I didn't. You said she, right?
Yeah, I'm gonna get right all over. There, I need some here. Can you start messing around?
Wait a minute.
Got it?
No reason to get mad.
Wait, why do you just randomly have a ball on your room? You done.
You really just close his
You know?
Oh, I think it's wrong. I like this is not
No. Why would you need to? Same idea. Same idea. Let's say you have, actually, I just have this open here. Where was it?
Find soda. Why do they call it soda?
Theta?
Yeah. Why do they call it?
Third. Because it's a third of the way there. Anyway, theta is the, don't draw this. I'm just showing you how this stuff is going to look. Theta is just the Greek letter for angle. That's what this is. Okay. Again, what will happen here is today you're going to be given some pictures that have some actual application to them, I guess. You know, a person standing 30 meters from a traffic light. Okay, cool. And if that, but that person kind of looks like a fire hydrant. That's pretty bad. Anyway, so they just so happen to know that the angle of elevation from the ground, they're doing it from the ground in this case, to the top of the traffic light is 25 degrees. How tall is said traffic light? Again, if you think about it, what do you do to start the problem?
Don't you circle the 25?
Yeah, you circle it. Your third up.
The third. So
And you would use.
tangent.
Okay. Again, this one happens to be another tangent one. You'll notice this stuff works rather quickly. Opposite. And just like you said, Christian, it was. How much? 13.99 meters.
That's all time?
Yes, sir.
Wow.
So, if I'm not mistaken, it's about what, 14 meters? So it's a little more than 3 feet. So that's what? That's a really tall traffic light. That's 40 some odd feet tall. I don't think traffic lights are that tall.
I mean, I guess it's just all the movement.
So, again, it's kind of iffy. Now, the one that's going to be different, oops, let me drop this one. The one that's a little bit different is this angle of depression. Angle of depression is line of sight looking down. Okay. Now, what happens here is you get this angle of elevation is looking up. This is your elevation. Depression is here. I don't, but if you want to run to the restroom, go for it. Okay. Your angle of depression is the line of sight looking down. I want you to notice that the angle of elevation and the angle of depression are always going to be equal. Okay? They're always going to be equal. They're congruent because line of sight looking down, and then if you have line of sight looking up, excuse me, those line of sights are always horizontal. You get a transversal, and you wind up with alternate interior angles. So, angle of elevation is inside the triangle. Angle of depression is outside of the triangle if you drew it. Depending upon the problem, you're going to, more often than not, if you start with an angle of depression, you'll just rotate it to the inside of the triangle and work your way through. Okay. Let me go from that. For example, okay. So, let's see. This one was. just did this one earlier.